Now in this question we have to identify the correct statement. So the first statement says K3CuF6 is paramagnetic and sodium nitroprusside is diamagnetic. Second statement says potassium AgF4 and K3CuF6 are diamagnetic. Third statement says CO-En Cl3 and K3CuF6 are paramagnetic. And the fourth statement says sodium nitroprusside is paramagnetic and COEN3Cl3 is diamagnetic, where En is ethylene diamine ligand. Now we have to apply the valence bond theory here to predict the magnetic behavior of each of these complexes. Now let us start with K3CuF6. So the central metal atom here is copper. Okay. Now the oxidation state of copper in this complex. So potassium plus 1. So 3 into plus 1 is plus 3. Copper is X and fluoro is minus 1. 6 fluoro atoms, so minus 6, and the total charge on the complex is 0. So X comes out to be plus 3. So the oxidation state of copper in this complex is plus 3. Now copper, what is the valence electronic configuration of copper? Copper is 3d10-4s1. And in the plus 3 oxidation state, the valence electronic configuration becomes 3d8-4s0. So 3 electrons gone. And now the d8 arrangement. And now before filling the d8 copper electrons, Cu plus 3 electrons, what kind of ligands it is attached with? So it is coordinated with fluoroligands, which is a weak field ligand, and it will favor no pairing. So we now accommodate the 8 electrons in the 5 3d orbitals. So first singly occupied up to 5 electrons, then 6, 7, 8. Okay. So since there is this weak field fluoroligand and there is no pairing, so obviously these 2 electrons will be left unpaired. Okay. And that is why this complex will be paramagnetic. Okay. So now we got that K3CuF6 is paramagnetic. Now coming to KAgF4. Okay. Now the oxidation state of silver here, what is the oxidation state? So potassium is plus 1, silver let us suppose X, and 4 fluoro ligands. So minus 1 into 4 is minus 4, and then total charge on the complex is 0. So X comes out to be plus 3. So silver is plus 3 charged here. Okay. Now what is the valence electronic configuration of silver? Now just like copper, if you remember the periodic table, silver is the second last element of the 4D transition series. So the valence electronic configuration is 4D 10 5s1. And just like copper in the previous case we saw, silver plus 3 oxidized becomes 4d8 5s0. Okay, now we have to arrange these 4d8 electrons. And before that, let us check the nature of the ligand that is coordinated to silver. It is again fluoro and a weak field ligand which will not favor pairing. And now we arrange the 4d8 electrons like we arranged in the case of Cu3+. So similar, Ag3+. We have D8. Okay, so 5, 6, 7, 8. And here also, due to the presence of weak field ligand, these 2 electrons remain unpaired. Okay, and that is why this complex KAgF4 is also paramagnetic. So option 2 is not correct, where it is given that KAgF4 is diamagnetic. Okay, now moving on to COEN3Cl3. Let's check this complex. Now for COEN3Cl3, again the same steps, the oxidation state of cobalt first. Supposing cobalt as X, En3 is uncharged, plus 0, and then 3 chloroligands, okay, 3 chloroatoms, and minus 3 is equal to 0. Total charge on the complex is 0, so X comes out to be plus 3. So cobalt is plus 3. Now what is the valence electronic configuration of cobalt? So valence electronic configuration of cobalt is 3d7 4s2. Now cobalt in the plus 3 oxidized state becomes 3d6 4s0. Now what about the nature of the ligand? The ligand here is ethylene diamine, which is a strong field ligand which favors pairing, okay, pairing of d electrons. Now we arrange these d6 electrons in the 3D subshell, so 5 and 1 6. Now due to the influence of these ethylene diamine ligands, what happens? Pairing occurs, okay, and that is why this electron shifts here and this one shifts here and gets paired. So this is the situation after the pairing has occurred. So like this. Okay, so do we have any unpaired electrons? No, we do not have any unpaired electrons here. So the nature of this complex is diamagnetic. So COEN3 Cl3 is a diamagnetic complex. Now coming back to the question, after COEN3 Cl3, what we are left with? So we have another complex, sodium nitroprusside. Okay. So up till now, we can predict that either option 1 or 4 could be the correct answer. Now let's check sodium nitroprusside. Now sodium nitroprusside, so the general or generic name is given here in the question, but it is always good if we know the chemical formula of this compound. So sodium nitroprusside is Na2FeCN5NO. The IUPAC name of sodium nitroprusside is sodium pentacyano-nitrosyl ferrate 3. Now the oxidation state of iron in this complex. So supposing iron is X, so 2 sodium, sodium is plus 1, so plus 2. Then 5 cyano, cyano is minus 1, so minus 5, and nitrosyl has a plus 1 charge. Total charge on the complex 0. So X comes out to be minus 5 plus 3, so plus 2. So iron is in the plus 2 oxidation state. The electronic configuration of iron, the valence electronic configuration is 3d6 4s2, and in the plus 2 state it becomes 3d6 and 4s0. Now what kind of ligands are coordinated with this iron? So cyano is a strong field ligand and nitrosyl is also a strong field ligand, and that is why pairing of d electrons is favored for this complex. Okay, so the 3d electrons can be filled like this, so 5 and 1 6. Now after they are coordinated with the strong field ligands, these electrons are paired. So after pairing, this one goes here and this one goes here. Okay, so after pairing, here is the picture of 3d electrons. So since no unpaired electrons in this case, so that's why this particular complex sodium nitroprusside is diamagnetic. Now coming back to our question, so we had sorted out option 1 or option 4 should be correct, where K3CuF6 is paramagnetic. That's fine. K3CuF6 is paramagnetic and sodium nitroprusside is diamagnetic. Yes, we saw here that sodium nitroprusside is diamagnetic. And what was the fourth option? Fourth option, we had sodium nitroprusside is paramagnetic. No, it is not correct. So the correct option for this question will be option 1. So I hope this explanation is quite clear to you, and it is one of the questions that has been asked in the competitive examination. So it should be helpful to all the students who are preparing for any competitive examinations for chemical sciences. And thank you so much.